Finally, we can try to determine what is the best measure of spread. So we're going to analyze each of these situations, which measure of center would best describe the data and explain. And explaining in statistics is a big part of it, being able to write and explain your answers. There could be more than one answer to these as long as you can justify your answer. So researching the employee salary at a specific company, I would say probably the median is the best way to use that one, the best center to use that, simply because similar to up here where one salary really increased the mean a lot, but one salary is not going to affect the median. So again, a supervisor or a boss is probably going to get paid a lot more than the rest of the employees. So using the median for Part A is the best measure of center. The attendance of football game at a certain high school, I would use either the mean or the median for this one. You could make a case for both. The mean is what's most often used when we're looking at attendance for sporting events. Add them all up and divide by how many there are. Gives you a good indication where we're dealing with that. Although a case could be made for the median because let's say that it is a big football game with a lot of people that's going to attend, but the rest of the season is kind of low-key football games where the visiting team may not travel very well. That one game with high attendance could affect the measures of spread a lot more. So the mean probably would not be a good thing, but the median would be a good indication on that one. But I would probably say more likely the mean is the best indication for that one. Basketball player negotiating his salary. Now, in the case of the basketball player, he's going to probably want to use the mean because he's going to want to include those high salaries of the stars in the league. He's going to want to include the LeBron Jameses in his salary to try to increase his own salary. So he would probably want to use the mean for his benefit. Now, if it was the case of the bosses or the general manager or the team owner, he's probably going to use the mode because most players are going to make the league minimum. So he's going to use the mode saying that, well, most players make this amount, so you probably should make this amount too. And that's probably going to be a very low number. And then finally, planning a food budget by analyzing the monthly costs for the previous year. You could use a case for either the mean or the median for this one. Again, you don't necessarily spend the same amount each month. You probably spend more money around the times of holidays and in the winter where you have to bring in produce from far away. So the median would be a good indication of that, but I could see that mean would be a good measure of spread for this one as well. Second part of this lesson is about percentiles, and that's something you've probably heard of before when you take your standardized tests and your score is often given to you as a percentile. What that means is it's a measure that often is used to report test data such as standardized test scores, and percentiles measure rank from the bottom and tell us what percent of the scores were below a given score. So if you score in the 60th percentile, that means you scored higher than 60% of all the people that took the test, including yourself. The lowest score is the first percentile. Since the percentile is based upon how many people or the percent of what you scored above, you can't score below or above yourself, so that's why there's no such thing as the 0th percentile. Highest score is the 99th percentile for the same reason. You can't score higher than yourself, therefore you can't score a 100th percentile, so there's no such thing as a 0 or 100th percentile rank. So computers are often used to find percentiles of test data because you have so many students that are taking the same test. But the process for doing so is that the test data or whatever data you're dealing with is ordered from greatest to least. And then you count the number of data values that are below a chosen element, meaning a chosen score. and you divide that by the number of values in the set. And you do also include the chosen score in the number that's in the set. And then you multiply the value from step 2 by 100, or you could just move 2 decimal places to the right and then round to the nearest whole number, and that will give you the percentile rank. So a talent show was held for 20 finalists in Teen Idol contest. Each performer received a score from 0 to 30, 30 being the highest. Find Victor's percentile rank. So I've already gone through and ordered these scores from the greatest to least. So the highest score was 29 and the lowest score was a 4. And to find Victor's percentile rank, we first have to figure out what did Victor score. And Victor is right here. Victor scored a 28, and his score is right over here. It's this 28th, which is near the top of all the scores possible. So the number of scores that are below Victor's rank, 27, 26, 25, and so on, that is 18 total scores are below his rank. And there are 20 total scores, 20 students or 20 performers performed, and 18 divided by 20 is 0.9. So to change that to a percentile, we can multiply that times 100, or a quick way to multiply times 100 is to move the decimal 2 places to the right, fill that in with a 0. That would give me 90. So we would say Victor scored in the 90th percentile. Notice I didn't say 90%. It's not a percent. It's a percentile to represent that he scored higher than 90% of all the performers. Question number 4 says to find Fernando's percentile. Fernando's percentile is right here. And it looks like Fernando just scored a 15. 15 is in this position right here. So the number of performers that scored below him are 1, 2, 3, 4, 5, 6, 7, 8 out of the 20 performers, including himself. 8 divided by 20 is 0.4. And 0.4, move the decimal 2 to the right to change that to a percentile, would be the 40th percentile. So he scored in the bottom half of all the performers, only in the 40th percentile. So percentiles can often give you a more accurate representation of where a person ranks. It's just one of the ways that we'll go through in this class. If I go back to the data set from the part 1 video up here, which was talking about the hits, the data set was 0, 3, 3, 4, 6, 7. So that was already put in numerical order. So 0, 3, 3, 4, 6, 7. And let's go ahead and put that from greatest to least instead. So it'd be 0, 3, 3, 4, 6, 7 this way. And let's say I wanted to know what percentile was the 3 hits at. So even if I look at this 3 right here, the number of days that he hit less than 3 was only 1 day, 0. So the percentile of 3 hits was it only occurred 1 day that he hit less than 3 out of the 6 days, which is 0.16 repeating. And if I change that to a percentile, I move the decimal to the right, there would be a 6 still here because the 6 is repeating. That would round up to the 17th percentile. So even though the number 3 is actually very close to the center of this data set, it's a very small data set, since there was a duplicate 3 right next to it, you can't count that as being one of the scores that was below this 3 right here. So the only time he had less than 3 hits was only the one time here. So that's why we can only use 1 divided by the 6 total hits to put him in the 17th percentile.